Okay, Bismillah Rahman Rahim. Uh, Till the midterm, we have discussed gaseous dielectric and the liquid dielectric and the factors that are affecting their breakdown strength and the various energy processes involved in the breakdown of dielectric materials. And we have also studied the mechanism and the theories which explains the breakdown process of gaseous and liquid dielectric. So now, in the final term course, we will start with the breakdown of the solid dielectric. Okay, so the function of any dielectric material, whether it is liquid, gaseous, or solid, is to insulate one current carrying circuit from other circuit. The solid materials have higher breakdown strength than the gaseous and the liquid. We have already discussed that the solid materials have the highest breakdown strength as compared to that of the gaseous and the liquid. So, uh, when the breakdown occur in the solid, it is permanently damaged. We have discussed this point in earlier classes that the solid are when the breakdown occur in the solid, they are permanently damaged. While in case of the gaseous and the liquid, the permanent damage is not occurred because these are the fluids and these have the ability to what they have the ability to recover, to flow, and to recover itself. So damaged solid materials cannot recover their original breakdown because these are not the fluids. These cannot flow. These have no ability, just like in gaseous and the liquid. So the fresh particles can not replace the damaged particles. Okay, so once a hot spot occur in any solid dielectric, so this will be affected and will causes increases its effect more, and side by particles will also be damaged, and initially the partial breakdown will be occurred, but later on as the time goes and the electrical stresses increases, so it will lead to the complete breakdown of the solid dielectric. Okay, so solid dielectric must have high dielectric strength. Okay, and this must be high for any dielectric, but for the solid it is also the same. Low dielectric losses, the losses should be low. The high mechanical strength. Okay, because solid, the one big advantage of solid dielectric is to support the conductors, because as you can see in the string insulators, these are the insulators in the form of string. So what will happen, this one will support the conductor. Okay, so uh, if these have the low mechanical strength, then uh, it will not support the conductor. It would not have the ability to support. So for any good solid dielectric, the mechanical strength should be high. Okay, okay, and these should be free from moisture. Means when the rain is raining or any moisture occur, so if this is porous, if there are small pores in the solid dielectric while manufacturing, so what will happen, the the raindrops or the moisture of the air will absorb in these pores. Okay, so uh, while manufacturing solid dielectric, these must be free from the pores so that no moisture and droplets can absorb, because the moisture can badly affect the dielectric strength of the solid dielectrics. Okay, so these are the factors that affecting the breakdown of the solid dielectric. One is the ambient temperature, means the temperature of the environment, because when any dielectric is exposed to electric field, so two types of temperature will be well imposed on the solid dielectric. The one is uh, the temperature caused by the current flowing through the insulator, and the temperature of the environment. Okay, okay. So ambient temperature, mechanical strength we have already discussed, impurities, gaseous inclusion, water, and the moisture. Okay, we have already discussed these, that the moisture and the water droplets can act as the impurity for the solid dielectric, because it will reduces its dielectric strength. Okay,
Sir,
yes,
sir, what does that mean by ambient temperature, sir?
the environment temperature, the environment temperature. Okay, okay. So I've told you that two types of temperature will be experienced by any insulator. The one is the internal, which is formed by what? By the current flow, and the other is the external, which is due to the temperature of the environment. Okay, so these two can affect the solid dielectric. So for any good solid dielectric, the solid dielectric must be uh, thermally stable. Okay, if it is thermally stable, so it means it can withstand both these type of temperatures and the heats. Okay, and later on we will study that how the temperature can affect uh, the breakdown strength of the solid dielectric. Okay, so there is a theory, the thermal breakdown. So in the thermal theory, breakdown theory, we will explain in detail that how temperature can affect the breakdown strength of the solid dielectric. Okay, so one is the chemical deterioration, means if any chemical process involved, for example, uh, the pollutions, the greenhouse gases, the ozones, so these can affect the breakdown of the solid dielectric. Okay, and the permittivity of the materials, mean the glass have different permittivity, the mica has different, the ceramics have different, so the polyvinyl chloride have different, so the different nature of the material have different permittivity. So that material will be good having a high permittivity. Okay, so the principal mechanism for the breakdown of the solid dielectric is the intrinsic breakdown. Okay, the electrochemical mechanical breakdown. Okay, these are the breakdown processes. Okay, I was talking about this. Okay, thermal breakdown in ambient temperature, we will study this. Okay, so these are just the list and the names of the breakdown processes, and we will discuss these one by one in our upcoming slides. Okay, so For the time being, just listen to the names: that intrinsic breakdown or the ionic breakdown, the electromechanical breakdown, the thermal breakdown, the electrochemical breakdown, the treeing and the tracking mechanism. Okay, so here we go for the detail one by one. The first, okay, first of all, we will just explain and demonstrate that how these mechanisms affect the breakdown strength with respect to the time. Whenever a solid dielectric is exposed for a short period of time, so it means there is a chance the dielectric strength will be high, because the, the electric stress is applied for a very short interval of time. Okay, so in this case only intrinsic or the electromechanical breakdown can occur. Intrinsic means if the breakdown occur for this very small amount of the time voltage applied, and still a breakdown can occur despite of having the higher dielectric strength. So it means this breakdown may be due to the manufacturing fault. Intrinsic breakdown is due to the manufacturing fault. We have applied the voltage for a very short interval of time. Okay, and despite of the high dielectric strength, still the breakdown occur. It may be due to the manufacturing faults. Okay, while manufacturing the solid insulator, there may be some pores or defects and the cracks, so that is why a breakdown can occur. Okay, the second reason may be the electromechanical stress. Okay, when the electric field is applied, so you know, a stress and strain, these are the mechanical processes. Okay, so the stress and strain can occur, uh, can be occur by the electric field. Okay, when the electric field is applied, it may contract, it may expand. Okay, it may compress, it may expand due to, not due to the physical force but the electrical force. Okay, the electrical force have the ability to compress or expand any material. So it depend upon the elasticity of that material. Okay, you know, every material has its own elasticity. For example, the rubber has high elasticity, and the ceramic have the low elasticity. Okay, so the electromechanical breakdown is actually due to that compression that occurs due to the application of the electrical stress. Okay, uh, when we applied the voltage for little bit higher time, so the dielectric strength will be weakened, because now the stress is applied for a a large duration. Okay, as soon as the electrical stress is applied for the large time, it means the electrical stress is going to increase, and due to which the breakdown strength will be reduces, because as soon as the we have applied the voltage for 1 hour, and then we expose any insulator for the 10 hours. So what does it mean? It means now the insulator has experienced a large amount of stress, because the voltage is applied for the high duration of time. Okay, and for 1 hour, it just the solid dielectric is experiencing the dielectric strength for very low duration, only 1 hour. Okay, so as soon as the time duration for the application of the voltage increases, the breakdown strength increases, and we can say that thermal breakdown can occur at this stage, or the erosion and the electrochemical breakdown can occur at this stage. Streamer can occur at this stage. Okay, so this is just for the convenience. We have divided the time scale of the voltage application into region in which different mechanism operate. Okay. Okay, now we will discuss these mechanisms one by one. Okay, so first of all, we will start with the intrinsic breakdown. Okay, so when the voltage are applied only for a duration of the order of 10 raised to the power minus 8 second, which is a very much low time. Okay, very much low time means the second has been divided into 1 divided by 1, 2, 3, 4, 5, 6, 7. Okay, so 1 divided by unit 10, 100,000, 10,000, lakh, 10 lakh, crore. Okay, so 1 crore, and the 1 crore unit of the second. So this is very low duration of time. Okay, so when the voltage are applied only for a very short interval of time, and the dielectric strength of at this stage is increases very rapidly due to the upper limit called the intrinsic dielectric strength, because uh, for a small amount of time we have applied the voltage. So it means that the stress will be low, and indirectly we can say that the dielectric strength uh, is increased. So experimentally this highest dielectric strength can be obtained only under the best experimental condition. Okay, so the maximum dielectric strength recorded experimentally is how much? 15 megavolt per centimeter, means for 1 centimeter duration, sorry, 1 centimeter gap. This is the electric field, the electrodes. Okay, and this gap is 1 centimeter. If you remember, I have demonstrated the gap effect in the some experiment of the gaseous dielectric. Okay, so if we have 1 centimeter gap and uh, a huge amount of 15 megavolt is applied. Okay, so then the breakdown strength occur. Okay, so it means that it has a very high dielectric strength, and that is recorded for the polyvinyl alcohol. Okay, at minus 196 degrees Celsius. Okay, so the intrinsic breakdown occur upon the presence of the free electrons, which are capable of the migration through the lattice of the dielectric. Okay, now if we have the presence of free electrons, and you know that solid materials are compact and they are closely packed, there is no chances of the free electrons in the solid. In gaseous we have the free electrons, and in liquid these are packed but not as much as we have in the solids. In the solid we have a highly packed electron. So how these free electrons come from? These electrons are actually comes from the the structural imperfection. If in the industry, if the industry in the industry we have these insulators are not manufactured in a good manner. So means if we have the pores. Okay, so these are actually the structural imperfection, and a small amount of impurities are present. So these causes actually the presence of free electrons in the lattice, in the layers of the dielectric structure. Okay, so that is why the breakdown, intrinsic breakdown is occurred. And I have already told you that intrinsic breakdown is due to the structural imperfection. Okay, now We have two types of the intrinsic breakdown. The intrinsic breakdown may be because of the electronic breakdown and the avalanche or the streamer breakdown. Okay, so
Sir, structure imperfection means there are some few free electrons.
structural imperfection means I have already told you that solid doesn't have the free electrons. In solid,
Yes, sir.
the electrons are closely packed, but if there is some imperfection means there are some pores and some cracks while manufacturing the solid dielectric. So due to
Okay, sir.
these cracks and these pores, what actually happened, the free electrons are now produced because the bonding is not that much strengthened. So
Okay, sir.
loosely packed electrons are produced, and that is why the breakdown strength is reduces, and the breakdown will occur, and we call this breakdown as the intrinsic breakdown. Okay.
Okay, sir.
Okay, now move on. We have two types of electronic breakdown. Okay, now the electronic breakdown is actually intrinsic breakdown occur in the time of the order of 10 is power minus 8 second, and therefore it is assumed to be electronic in nature. When the electric field is applied, electron gains energy from the electric field and crosses the forbidden energy band from the valence to the conduction band. This is the same process we have already discussed, that when the electric field is applied, what happened, electrons gains the energy, okay, from the external agency, and it crosses the forbidden band, as we have discussed already in the midterm course, that the energy band theory, electrons are somewhere here in the valence band, and this is the forbidden band. Okay, so when these electrons get the energy, when the voltage is applied, so what will happen, these electrons have enough energy to cross this forbidden band region and jumps to the conduction band. Okay, so when the electric field is applied, okay, these electrons gains the energy from the electric field and crosses the forbidden band, okay, from the valence band to the and jumps from the valence band to the conduction band. Okay, when this process proceeds continuously, more and more electrons get collected in the conduction band, and it leads to the complete breakdown. Okay, from just one electron jumping, the breakdown will not occur, but if this process is continuing and more electrons gets the energy from the external electric field, so these electrons will be able to jump to the conduction band, and ultimately the breakdown will occur. There is no collision involved in these electrons, but when the collision are involved, so what will happen, the cumulative ionization will occur. Okay, the conduction, this is similar to the breakdown in gases due to the cumulative ionization. The conduction electron gains sufficient energy above the certain critical electric field and causes the liberation of the electrons from the lattice, okay, by the collision. Okay, so the only difference in the electronic and avalanche is the collision. In 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 electronic breakdown, the electrons gets the energy from the external agency only, and it jumps to the higher conduction band. But in the avalanche or the streamer, the electron gets energy from the external, as well as these electron collides with each other due to the manufacturing fault, and the electrons that are present from on the crystal lattice. Okay, so these causes collision with each other, and accumulate, and the cumulative ionization will occur. Okay, and these can be represented just like that. This is 1 2 3 4 5. It means due to the manufacturing, defect, cracks are present and it increases, and these cracks are now increased when applied to the electric voltage. Okay, so a stream will be occurred. Stream means nadi. So a stream will be occurred. Okay, a series of electron ionization will be occurred. So it started from 1 and ends to 18. Okay, and a branch is, and the tree like structure is actually occurred. Okay, so we can say that an avalanche is occurred. Avalanche means flood. Okay, the flood of ionization occurred. So that is why it is called, also called as the avalanche or the streamer breakdown. Okay, and these two are the types of the intrinsic breakdown, and these two are both, the reason for both these breakdown is the manufacturing part. Okay, now we have the electromechanical breakdown. Okay, so as I have already discussed briefly that what actually happened when the electric field is applied. Okay, so when the electric field is applied, so a compression will occur. Okay, and we call this compression as what, the strain means, the definition of the strain is the change in length divided by the original length. Means if we have no change, so the strain value will be 1. Okay, and we have if we have the value less than 1, so it means that the compression has been occurred. Okay, this is d naught. Okay, d naught is the change in length. Okay, if we have, this is the original length of any solid dielectric. Okay, and when electric field is applied and it is shrink to just like this. Okay, so it means a change has been occurred in the length. Okay, if it was 1 feet for example, means 12 inches. Okay, and now it is reduced to 8 inches. Okay, so it means the value will be 8 change in length. Okay, 8 minus sorry 12 minus 8, 4. Okay, so 4 divided by the 12. Okay, this is actually change in length. Okay, 12 minus 8 means 4. So 4 divided by 12, this is the change in length. And this change and this compression or shrinking of the material is occurred due to, not due to the physical force but due to the electrical force. Okay, so when the dielectric material is subjected to the electric field, the charges of the opposite nature are induced on two opposite surface of the material. Means when the electric field applied, so this will be positive, sorry, this will be positive and this will be negative if the compression is occurred along this. And if the compression is occurred from top to bottom, so what will happen then, it will be reduces like this. It will be thinner than the original length. So now in this case the electrons will be deposited over here, and this causes the shrinking of this material. Okay, not on lengthwise but on the the thickness wise. Okay, the thickness wise. So and hence a force of attraction is developed. Okay, the force of attraction will be occurred between these two. So it will uh, this surface will be moving towards up, and the upper will be moving towards down. So by this force of attraction between the upper and the lower surface, what actually will happen, the material will be thinner. Okay, hence a force of attraction is developed and the specimen is subjected to the electrostatic compressive force. Okay, these compressive forces are not due to the physical compression but due to the electrostatic. Means the static charges compel these material to be compressed. Okay, so that is why it is called as electrostatic compressive forces. When these forces exceed the mechanical strength of the material collapse. Okay, so there will be mechanical strength of this material. So if the force is exceeding, and if this is so exceeded that it reaches the breakdown or the critical value of this material, then what will happen? It will collapse. Okay, if the initial thickness of the material is d naught, okay, and it is compressed to the thickness g. Okay, so I was wrong. This is actually the initial, okay, the initial thickness, and the compressive is then this d. Okay, so this will be not 12 but it will be 12 by 4. Okay, under the applied voltage, then the compressive stress developed due to the electric stress will be this. Okay, this is actually the electrical stress, and this is actually the strain. This is stress, this is stress, this is strain, and this is why. What is why is the Young's modulus? Okay, according to the definition, Young's modulus is defined as the stress over strain. Okay, this stress is the force applied, and the change occurred in the length is actually the strain. The change in length is the strain, and the applied force is the stress. So stress over strain is called the Young's modulus, and it defines uh, the elasticity of any material. Okay, so we will discuss the electromechanical breakdown and some other theories in the next class in detail. Today the strength is very low, so we will finish the class now. Okay, so if you have any question, you can ask.